Hello. Today we will start with a completely new topic. So we are done with all forms of mechanics. We are done with an object that is moving in horizontal motion or in a projectile motion or a mass spring system or vibrations. We are done with all types of mechanics. We will start with electricity. In particular, we will start talking about electric charges, insulators, conductors, electric forces, electric fields. Perhaps some of you remember Coulomb's law. So these are terms we will encounter in this chapter. Let's start with things that are very, very simple. I think this is an experiment we all do at some point in our life. We bring a comb and we rub it against our clothes or against our hair. And we start observing that it can attract pieces of paper. So we also did it with pens, with the Bic pen. We would rub it against our clothes or against our head, and then we start observing that it's absorbing, it's attracting pieces of paper. Another example is the balloon. We can also rub the balloon against wool, and we will observe that it can start attracting hair of this girl over here. This thing happens a lot in dry weather, especially these days. If we come to comb our hair, we start noticing that the comb is attracting our hair, or it makes some sound, which means there are some electric forces, some electric things is happening. Okay. Now some definitions. Electric charges are electrons and protons. Okay, so we either have an electron or we have a proton. These are called electric charges. An object is negatively charged. We say an object is negatively charged if it has excess electrons. Okay, an object is negatively charged if it has excess electrons. An object is positively charged. It is positively charged if it has excess protons. Okay, we represent charge by letter Q. So we say Q is equal to blah, blah, blah. Its unit is Coulomb, just as the unit of force is Newton, the unit of mass is kilogram, the unit of any charge is Coulomb. What are the charges? Electrons and protons. The charge of one electron is Q equal to minus 1.6 times 10 power minus 19 Coulomb. Okay, the charge of one proton is exactly the same amount, but it is positive. So it is a plus 1.6 times 10 power minus 19 Coulomb. We have to remember these numbers. Now, for example, if I give you an object and I say, find the charge of an object that has 3 electrons in excess. Okay, what is the charge of an object that has 3 electrons in excess? We will come and say Q is equal to electron, the charge of it is minus 1.6 times 10 power minus 19 times 3. This will give me minus 4.8 times 10 power minus 19. So I multiply 3 by the charge of one electron to get the charge of an object that has 3 electrons in excess. Okay, more on electric charge. There are some experiments that were done and people have made some observations. For example, in one of these experiments, a negatively charged rubber rod suspended by a string is attracted to a positively charged glass rod. So they brought a negatively charged rubber rod and they brought a positively charged glass rod, and they observed when these two rods were brought close to each other, they attracted each other. Okay, they attracted each other. On the other hand, they observed when a negatively charged rubber rod is repelled by another, they observed that a negatively charged rubber rod is repelled by another negatively charged rubber rod. So overall, they observed opposite charges attract each other, similar charges repel each other. Opposite charges attract each other, similar charges repel each other. Okay? Now, let's talk about insulators and conductors. Perhaps you already know this, but let's mention it quickly. What is a conductor? A conductor is an object where electric charges move freely in response to an electric force. Example to that is iron, copper, gold, silver. So what happens? If I bring, for example, this conductor, let's say it's an iron ball, and I bring a negatively charged rod. Once I bring this negatively charged rod on the conductor, all the charges come on it and they redistribute all over it. Okay, so the charge quickly distributes itself equally across the sphere. However, in objects like insulators, examples of insulators is plastic, rubber, glass, wood. They observed if I bring a negatively charged object close to it, it would attract positively charged charges on the side, and they will stay here. They will not redistribute them equally across the sphere, or at least it will not do this very quickly. Okay, it will take time. How to create charged objects? There is several ways. One of them is charging by conduction. So we start by a neutral sphere. When we say neutral sphere, it means it has equal numbers of positive and negative charges. Okay, so we have a neutral sphere which has equal numbers of positive and negative charges. Then I bring a negative rod, for example. I don't make it touch the sphere immediately. I start by bringing it close to it. Once I bring it close to the sphere, the positive charges will be attracted to the rod, and the negative charges will go to the other side. Okay? Then I make contact. Once I make contact, all the positive charges will move to the rod. All the positive charges will move to the rod. And what will happen to the sphere? The sphere will have extra electrons, and then they will redistribute on the whole sphere, and the sphere will become negative charge. Okay, so this is charging by conduction. Contact is required. Okay, there is also charging by induction where contact is not required. It happens the following way. So we also start by a sphere which is neutrally charged, that is, it has equal numbers of positive and negative charges. Then we bring a negatively charged rod close to the sphere. The positive charges will be attracted to the rod, and the negative charges will move away from the rod. Then what I will do is that I will ground the sphere. Okay, I will ground it. I will attach it to some wire. Once I attach it to some wire, all the negative charges on the side will move away. They will be out, they will be away. Okay, what will happen? What will happen now is that I can remove this rod, and I will have a sphere which has more positive charges, because most of the negative charges, they were removed by grounding. In this case, contact was not required. So this is charging by induction. Now, Coulomb's law. Coulomb's law says, if I bring two charges, Q1 and Q2, this can be a proton, this can be an electron, this can be 2 protons, 5 protons, this can be 10 electrons, whatever. If I bring one charge and another charge separated by some distance r, they exert on each other a force F. This force F is equal to K, some constant, multiplied by the charge Q1, multiplied by the charge Q2, divided by the distance R squared. Okay, and these two forces will be the same. So Q1 will be making on Q2 exactly the same force Q2 will be making on Q1. Now the side depends on whether these two charges are positive or negative. So if this is one positive and this is negative, they will attract each other. Okay, and if they are both positive or both negative, they will repel each other. But what matters here is that the magnitude of the force, is equal to K, Q1, Q2 divided by the distance squared. Okay, so Q1 is the charge for the first charge, Q2 is the charge for the second charge, and R is the distance between them. Let's look at directions. If Q1 and Q2 are positive, then F12 and F21. So what is F12? F12 is the force Q1 is exerting on Q2. Okay. F21 is the force Q2 is doing on Q1. If they are both positive, the forces are repelling. If they are both negative, also the forces are repelling. However, if one is positive, one is negative, then they are attracting. Okay? And what is the magnitude? Just keep in mind K, Q1, Q2 divided by R squared, where K is 9 times 10 power 9 SI units. Let's do an exercise. The electron and proton. So, one exercise. Oh, the electron and proton of an hydrogen atom are separated by a distance of about 5.3 times 10 power minus 11 meter. So here I have proton, the first charge. We have one proton whose charge is 1.6 times 10 power minus 19 coulomb, and one electron whose charge is minus 1.6 times 10 power minus 19 coulomb. Okay. They are separated by a distance d, or we call it r, 5.3 times 10 power minus 11 meter. Find the magnitude of the electric force that each particle exerts on the other. So we come to this rule, F12, that is the force the first charge exert on the other charge is equal to F21, which is the force exerted by the second charge on the first charge, equal to K, the absolute value of absolute value of Q1, absolute value of Q2 divided by R squared. So now I just plug numbers. K is given 9 times 10 power 9 times the first charge is 1.6 times 10 power minus 19 times the absolute value of minus 1.6 blah 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 is 1.6 times 10 power minus 19 divided by 5.3 times 10 power minus 11 squared. Okay, this is just a mathematical equation that we use a calculator to measure, and we'll get the answer to be 8.2 times 10 power minus 8. This is force, so the unit of it is Newton. Okay. You will find the solution here. Exercise 2, what is the electric force? So again, we have to use the force, the electric force between a glass ball that has Q1 equal. So we have Q1 equal 2.5 micro coulomb. Okay, what is micro? Let's put it here. Micro is equal to 10 power minus 6. Okay, so this is equal to 2.5 times 10 power minus 6. coulomb. Okay, and a rubber ball whose charge Q2 is equal to -5 microcoulomb. So -5 times 10 power -6 coulomb, that are separated by a distance of r is equal 5 centimeter, which is 0.05 meter. Okay, so what is the electric force? So F12 is equal to F21 is equal K, absolute value of Q1 times absolute value of Q2 divided by R squared. Okay, so this will give me K 9 times 10 power 9 into Q1, which is the absolute value of the Q1 is 2.5 times 10 power -6 times the absolute value of -5, it means 5 times 10 power -6 divided by 0.05 square, and the answer is 45 Newton. Okay. The last exercise we will do together today. So an alpha particle, charge for it is 2 electrons. So Q1 is equal, or Q1 is equal to 2 absolute value of electrons. So 2 times 1.6 times 10 power -19, right? This is the first one. Q2, 79 times 1.6 times 10 power -19 coulomb, where E is, okay, what is the electric force acting on the alpha particle when the alpha particle is 2 times 10 power -14 meter from the gold nucleus? So we have R is equal to 2 times 10 power -14 meter. So similarly, we say F12 or an alpha, so what is the electric force acting on the alpha particle? Well, the alpha particle. So F12 equal F21 equal K, absolute value of Q1 times absolute value of Q2 divided by R square. This is equal, K is 9 e to the 9 times Q1, 2 times 1.6 times 10 power -19 times Q2, which is 79 times 1.6 times 10 power -19, the whole thing divided by 2 times 10 power -14 squared. Okay. So we just do the calculations, and this will give me 91 Newton. Okay, so that's it for today's lecture. I would suggest that you try to solve exercise 1, page 49, so suggestion. Solve exercise 1, page 49. We will be doing it together tomorrow, but as a suggestion, try to do it on your own to see if you understand this. Okay, so that's it for today, and tomorrow is a new lecture. Bye-bye.